what is the value of k? Given that you have k times k times k plus k equals 2. Let's have, recall, when we have a times a times a equals a to the power of 3. So when we have k times k times k, it will also be k to the power of 3 plus k equals 2. So from here, let's take these two to the other side. So we have k to the power of 3 plus k minus 2 equals 0. Then from here, k to the power of 3 plus k, from here we can have here to be 1 plus 1, so give us 2 equals 0. K to the power of 3 plus k minus 1 equals 0. So from here, let's regroup this as k to the power of 3 minus 1 plus, from here, k minus 1 equals 0. Recall that we can have 1 to be equals 1 to the power of 3. So we can have here to be k to the power of 3 minus 1 to the power of 3 plus k minus 1 in parentheses still equals 0. Recall, from here, when we have a to the power of 3 minus b to the power of 3 equals a minus b times a squared plus ab plus b squared. So for this, our a will be k and our b will be 1. So when we substitute here, we have k minus 1 times, from here, k squared. 1 times k here will be k plus 1 squared plus k minus 1 in parentheses equals 0. So from here we have k minus 1. Here will be k squared plus k plus 1 plus k minus 1 in parentheses equals 0. K minus 1 is common. We can factor it out. Here will be k minus 1. So the whole of this divided by this, we have k squared plus k plus 1. This divided by this will also be plus 1 equals 0. We have k minus 1. Here will be k squared plus k plus 2 equals 0. So from here, for this expression to be equal to 0, we have k minus 1 equals 0, or we have k squared plus k plus 2 equals 0. Here will be k equals 1. Then to solve for this, we have to apply the quadratic formula. We have k minus b, positive or negative, square root of b squared minus 4ac divided by 2a. So where we have a parameter a, the coefficient of k squared, 1, parameter b, the coefficient of k, 1, and c equals 2. So here we have k, it will be minus 1 positive or negative, square root of 1 square, 4 times a is 1 times c is 2 over 2 times 1. So from here we have k minus 1 positive or negative. So this will be 1. 4 times this will be minus 8 over 2. So from here we have k minus 1 positive or negative, square root of 1 minus 8 will be minus 7 over 2. Then let us recall when we have root of minus a equals as root of a times root of minus 1, then root of minus 1 equals I in a complex space. So this will now be root of a times I. So from here we have k minus 1 positive or negative root of 7 times root of minus 1 over 2. So from here we have k minus 1 positive or negative root of 7I over 2. So meaning that we have k, also k equals 1. So this is a real solution. Why these are complex? Solution. So now let us now recall we have k times k times k plus k equals 2, meaning from inspection, when k equals 1, 1 times 1 times 1 plus 1 is going to give us 2. 1 times 1 is 1 times 1 will be 1 plus 1 which equals 2. 1 plus 1, 2 equals 2. So since the left hand side equal to right hand side, so k equals 1 satisfied. Then let us for when we have k equals 1 positive or negative square root of 7i over 2. Let's write this as k equals minus 1 plus 7 root of 7i over 2. We also have k minus 1 minus root of 7i over 2. Then to check, we have k times k plus k equals 2.